Okay, everybody, welcome back. Just one problem to work on here. It's kind of a big one. We're not going to do the whole thing. Definitely not. Manufacturer must describe a dimensioned part to its X and Y coordinates for a computer numerically controlled machine to produce it. These coordinates are measured relative to a datum. All right, remember way back when in algebra or whatever, and we had the x-axis and we had the y-axis, and this guy right in the middle, our point of reference, that's called the origin. Well, they're just calling it datum. Okay, so our origin, their datum, same thing. Okay, and their datum says is right here at the center of this circle. So it's right there. Okay, that's the origin. That's the datum. Okay, so just like the regular XY coordinate system, so left is negative X value and right is positive X value. Up is positive Y value and down is negative Y value. And so that's kind of how it goes. All right, so it says fill in the chart, which you can't quite see. Yeah, here's the chart right here. Fill in the chart with the X coordinate and the Y coordinate of each point. So if you plug that in, then into the computer, then the computer's able to, build this thing the way that you want. All right, so the first thing is P1. All right, so we look over here. Where is P1? Ah, there it is, right there. Okay, P1 is this bottom corner, bottom left corner. Okay, so P1, oh, whoops, didn't mean to do that. Let's do a different color. Okay, so P1 is going to be that corner right there. Now, we start at the datum. Okay, so let's do something easy. What's the Y coordinate? Well, to start at the datum and end up there, we're going to have to go down 3/4 of an inch. Okay. All right, so the Y coordinate is a negative 3/4 of an inch, or you can say negative 0.75. I don't care. I mean, they mean the same thing. Actually, let's just say negative 3/4, because this is all standard measurement, so it's all fractions. And I know we all love fractions. That's why we love, 1 foot and 8ths and 16ths. Okay, so we got that. What else we got? Okay, so we know how far to go down. That's the Y coordinate. What about how far to go to the left? Well, we are going to the left from the datum, so the X coordinate is also going to be negative. Okay. Well, how far left? Well, looks like right here it says 1/4 to get from there to there. So -1/4. So that's going to be our answer to the first one. And of course, the first one is the easiest. But that does kind of get you familiar with what's going on. Okay. All right. What else have we got in our little bag of tricks? Okay, the next one is P3, which is right here, this corner, right there. Okay, so that's going to be this little piggy right there. And again, there's our origin. So this time our Y coordinate is going to be positive and our X coordinate will still be negative. Let's get the X this time first, I guess. Okay, so to get from the datum, the origin, out to our target, we're going to go to the left 1/4 and then another 1 1/4. So 1 1/4 and 1/4 is 1 1/2. So our X coordinate will be negative 1 1/2. Okay. Now, how high is that thing? How high? Well, compared to this guy here, how high do we have to go? I don't know. But I can see that if we go up 1 1/8, another 5/16, another 5/8, and another 5/16, that puts us at this height right here. Now, is that the same thing as this height? Maybe, maybe not. We don't have anything at this moment to guarantee that. It turns out, I think they're the same height, but nothing says Yeah, they are. So I don't want to assume, because that has a tendency to lead to bad decisions. Okay, so tell you what, why don't we just add on another 5/8? That'll get us to the top of the part. And then if we subtract another 5/8 to get back down, then we're there. Oh, wait a minute, add 5/8, subtract 5/8. Well, why don't we just skip both of those and stop with these 4 right here? Okay. So yeah, so apparently this guy right here that we're our target, he's down 5/8, but the top of but this line, oh, I didn't draw it very well. This line right here is also down 5/8. So yeah, so apparently they're at the same height. All right, so let's see what we got here. So we've got well, we've got 1 1/8. I'm just starting from the bottom, working my way up. Plus another 5/16, plus a 5/8, plus a 5/16. Okay, cool. Hey, let's combine like terms. Okay, for example, 1 1/8 and 5/8. I can put those together and make 1 6/8. Cool. And then these two guys right here, 5/16 and another 5/16, that'll make 10/16. But I can cancel the 2 out of both of those, so that I get 1 6/8 plus 5/8. Now, yeah, I could cancel a 2 out of these two, but I don't want to, because I want them to have the same denominator. That's why I didn't cancel those. All right, so I add them together. I get 1 11/8, but I don't want the top being bigger than the bottom. Okay, so 11/8 of an inch. Let's see, that's going to be, that'll give us 8/8 plus another 3/8. And I broke it off that way because 8/8, that's 1 complete inch. That's 1 plus 1 makes 2, with 3/8 left over. Oh, okay, well, that's kind of clever. So our y coordinate is 2 3/8. We go up 2 3/8. Now, my fancy calculator is actually going to do all that work for me, but you probably don't have that handy. I don't know, maybe you do, but maybe not. At least that's how it usually goes in most of my classes. Okay, so we got that. Let's maybe do one more of these. All right, let's do P7. Okay, now notice P7 is right here. It's not, over there along the edge. It's just sort of this imaginary point in the middle. So where's that? Well, let's see if we can figure that out. Okay, P7. So P7 is going to be about right there. Okay. Now, we are told in this problem that the radius of all the holes is 1/8. 1/8 inch radius. So from the center of the holes to the edge of the hole is 1/8 of an inch. Okay. Now, that also, if they didn't give us more information, that would be enough. But they also tell us, more importantly, right here, that the radius of these corners, these rounded corners, is also 1/8 of an inch. Well, what does that mean? It means if you were to finish that corner and draw a circle, it would also be a 1/8 of an inch circle. 1/8 inch radius circle. So we can use that to figure out where our target is on this one, because it's going to be the very center of the circle. Okay, so let's go get them. So starting at our origin, we're going to go to the right 1 1/2, which probably lines up. That takes us to there. That probably lines up, but I'm not totally positive. So I'm not gonna assume that. Okay, so let's go to the right 1/2, 1 1/2, then another 3/4. That takes us to there. And then let's back it up 5/8. Okay. Let me start writing that down because this is getting a little messy. All right, so we got 1.5 and another 3/4, and then we'll back it up 5/8. All right, now backing it up 5/8, that takes us to here. It doesn't quite take us to the center of the circle, but that's okay. We know the center of the circle is in 1/8 of an inch. So let's back it up another 1/8 of an inch. Hooray. Okay. And then that'll put us there horizontally. So what does that give us? Well, 1.5 and 3/4, that'll be 2 1/4. And then minus 5/8 and minus 1/8 will give us minus 6/8. That's cool. But we can cancel the 2's and get 3/4. Ooh, that's nice. And that'll take us back to 1.5. So yeah, if we had just done the original 1.5, that would have matched right up with it, like we suspected, but we didn't know for sure. Okay, so the x coordinate is going to be 1.5 inches, and it's positive because it's to the right of the whatever you call it, of the datum. Okay, now what about that y coordinate? Well, from the height of the datum, we got to go up 1 1/8. That gets us to right there. And then we just got to go up just the radius of the circle, another 1/8. So 1 1/8 plus 1/8 is going to be 1, whoops, and 2/8. And I can cancel the 2's and get 1 1/4. So up 1 1/4 inches. And that's kind of how you do these. Okay.